Good evening and welcome to Tuesday Talks at Rose-Hulman Institute of Technology. My name is Lisa Norton. I'm the Dean of Admissions, and I would like to welcome Dr. Mario Simoni from our Electrical and Computer Engineering Department. He's going to share with us a little bit tonight about just an overview of the department and be ready to take your questions for about the next 20 to 30 minutes here. So I'm going to turn it over to Dr. Simoni to tell you a little bit more about himself and about the department.
Hello, everyone. Thanks for being here tonight. So I'm Dr. Simoni. I've been a faculty member here at Rose-Hulman for about 20 years now. Been department head in the department for about 4 years. Some things about the department. Well, we have 2 degree programs. So we have an electrical engineering degree program and we have a computer engineering degree program. I'd be happy to answer questions. I think we already have some questions about the difference between those, so we'll talk a little bit about that. We have about 20 faculty in the department. The faculty love to get in the lab and help you with hands-on activities. They love working with you on homework questions. We love working with students. That's why we're here. One of the top things I think to say about our department is that we have a lot of hands-on opportunities. Almost all of our courses have a lab associated with it. So if you like to get your hands dirty, not literally, but if you like to get in the lab and do things, then this is the department for you. So I don't want to take up too much time. So why don't we go ahead and get into questions?
Yeah. All right, we did have some questions that were submitted in advance, and I'm going to start with a few of those, and please feel free to submit your questions as we go along here. But Luke from Georgia wanted some examples of jobs that computer science versus computer engineering versus software engineering majors might have. And then also if there were any specialty areas within electrical or computer engineering.
Right.
So it's kind of 2 questions.
So there's a lot of answers to that question. So I'll start with what's the difference between software engineering, computer science, and computer engineering. So software engineering is really focused on the design of large software packages. So if you think about Microsoft Windows or Microsoft Word, these are enterprise level software packages, or it could be an app for like Starbucks and ordering coffee, and you download an app on your phone. But these are large scale software packages that thousands of millions of users are going to use. And you have to be careful when you're designing those things because so many people are using it and it can react with so many other different pieces of software. It's a very complex system. So that's software engineering. Computer science is really focused on the software running on computers. How does the software work? How can we make it more efficient? But it's really focused on the algorithms and really understanding the nuts and bolts of software. Computer engineering is a mix of hardware and software. And it's understanding how the computer works, not just the software. And so computer engineering, you're going to get in the lab, you're going to build circuits, but you're also going to do a lot of programming. And so if you were to think about it, a lot of people come at these, and there's other questions about robotics. I think robotics is a good way to answer this question because it involves all of these different domains. So with robotics, the computer engineer, and if you've done any robotics in high school, you've used these boxes to control the robot, and mostly what you're doing is programming these boxes, these controllers for the robot. But in computer engineering, we get into actually building those boxes and designing those boxes and understanding how those boxes work. And if the box isn't working right as a computer engineer, you would know how to fix it, and you would know the limitations of those boxes, as well as being able to program the robot as a whole. Someone who is a software engineer might design an application that would simplify the programming or the control of a whole class of robots, right? So that would be software engineering. They're going to be focused on the design of the software package. A computer scientist might look at new algorithms for computer learning or for processing the computer vision and things of that nature, but it would still be focused on the software behind the robot. So I hope that explains a little bit about those differences. Then there was the second part of that question.
Right.
Can you repeat that?
Yes, the second part of that question is, Are there any specialties in computer engineering, electrical engineering that you can choose from?
Oh yeah, there's lots. So computer and electrical engineering are incredibly broad fields. That there just isn't time to go into all the different things you could do. But if I were to break it down into certain areas, there's fields like machines and power, which is your power generation, distribution, electric motors, electric vehicles, even the motors on like robots and things of that nature. So machines and power. There's circuits and analog circuit design. So this would be things like your radios in your cell phone that transmit with the cell phone base station. It could be a lot of sensors use analog electronics. So Texas Instruments is one of the big analog electronics people. You think they make calculators? They do a whole lot more. And then there's there's analog electronics. There's digital system design. So this could be like designing the central processing unit within your computer, designing graphics cards, those kind, anything that's digital based. And there's a lot of opportunities there. We have people go to work at Intel, the memory company. It's escaping my memory right now. No pun intended. And then so there's a lot of opportunities there. There's control systems, which is an area that most people aren't aware of in electrical or computer engineering. And so control system is like the cruise control in your car. And so if you're all you're doing as a user of the cruise control is pushing the button, but the car is doing so many things. So it has to sense how fast you're going. It has to adjust how much gasoline is going to the engine. And all of that stuff now is computer controlled these days. And there's all kinds of complex mechanisms and things involved in that. And so control systems involves programming and involves some mathematical modeling and higher level thinking skills related to how these control systems work and to make them functional and stable. So control systems design are instrumental in robotics. So any robotics company is going to do control systems. If you're wanting to get into autonomous vehicles, Tesla has control systems out the wazoo in their vehicles, right? And so that's another area that you could go into. Another area is signal processing. And so signal processing is the idea that we have sensors all around us that are collecting things. I'm going to use an example. Let's say we put several microphones in a room. And those microphones, if they're, if it's a party and there's all kinds of people talking and things going on, then the microphones are going to pick up these signals of everybody talking. Well, we can record that data coming from those microphones and put them on our computer, and then we can write some software, and we could maybe extract one person's voice, or we could track a person walking around the room using that software and those algorithms that we have for processing the data from the signal. So that's signal processing. It's used a lot in medical imaging. All your digital cameras, all your cell phones all have signal processing in them. And then there's electromagnetics, which is how antennas work. So anytime your cell phone communicates with the base station, it's sending electromagnetic energy back and forth. And so we have to understand that electromagnetics, as well as anything with radar. A lot of autonomous vehicle stuff now. My car has adaptive cruise control. That's all radar. That's all electromagnetic energy that we have to use to do that. Some other areas, communications is another one. Everybody's anxious for 5G cellular to come out. That's all electrical and computer engineering. Also computer networking. Anytime you're hooking your computer up to the network, that's all another area of computer engineering design. And so, yeah, I could go on and on and on, and I'd be happy to describe more to you if you want to contact me later. I've taken up a lot of time with this question, but this is a common question that a lot of prospective students want to know, and it's hard to get that information out there, so I love sharing it.
Yeah. Another question that we have is, do we practice electrical design in the curriculum?
We do a lot of design. So we start with your very first or second quarter as a freshman, and we have you in a freshman design class, and you'll be working with Arduinos. You'll be programming a robot, so it culminates, has a number of mini projects that culminate in a robotic competition at the end of that term. And so you'll be on a team with 3 students, and you'll be designing a robot, and you'll be have a competition with that robot at the end. So that's hardware and software all put together in one class. And then we have a junior design class where you will work on a more complicated project that comes at the end of your junior year. And then we have a year-long senior design project where you'll be doing a design project for a real-world client. So we have industry clients, we have non-for-profit clients. Like one of the projects this year is a team is designing a solar panel system for the Railroad Museum here in town so that they can electrify some of the railroad cars that they have on site. And so these are real world problems that you'll be solving, and you'll be on a team of students working all year on that. So we do a lot of design. Yep.
Very good. Another question we have is from Thomas in Indiana. It says, I'm in a dilemma about choosing between electrical and computer engineering. What are the differences in the curriculum between the two? And can you do a dual degree?
Okay, so another great question that I get a lot of. So that I talked a little bit earlier about the different areas of electrical and computer engineering. And so electrical engineering is more broad. So electrical engineering will cover machines and power, whereas computer engineering does not. Electrical engineering will do more with electromagnetics, whereas computer engineering doesn't do as much. Electrical engineering will do more with signal processing and with controls, whereas computer engineering has a little bit less of those. But computer engineering picks up in, they take some more computer science courses, they do more with digital system design. Oh, one area that I forgot to mention is embedded systems. That's super important. So that's a lot of what computer engineers do these days. And embedded systems is the idea of taking little computers like this Fitbit here, and this is a computer, but it's a computer with a specific purpose. It does the same thing over and over again. It takes in the same inputs and it produces the same outputs, and it interacts with the things around it. And so this is embedded computing. This is a lot of what computer engineers are doing these days, is powering things like the Internet of Things. It's making it possible for autonomous vehicles. All kinds of problems that we're trying to solve in the world today. We're using these embedded computers all over the place. So, let's see, I got lost track of what question I was answering there. Oh, what's the difference between electrical and computer engineering? So computer engineers will pick up more embedded systems. They'll pick up more on computer science. So they'll take some more computer science courses, and they'll do more with digital and with embedded systems than the electrical engineers. Yep.
Okay. And then the other part of this, maybe you caught that, could you do a dual degree?
Oh, dual degree. We in the past, we have not allowed a dual degree between electrical and computer engineering because they've been too similar, but they're starting to diverge now. And computer engineers are really taking a different suite of courses. So I don't know if in the future we'll allow double majoring there. But even if you can't double major, we have electives built into and some flexibility built into the curriculum, such that if you wanted to do electrical engineering but pick up a couple of computer engineering courses, you're welcome to do that. You won't get the credential of having a minor, but you can always explain to any potential employer that you're interested in computers and you took these extra courses and you have some expertise in this area. Yeah.
Okay, very good. Another question we have is if you could tell us a little bit about the placement most recently for your graduates.
Yeah. So if you want, email me. I can send you a list of about 200 companies that have hired our graduates over the last 10 years. I couldn't even, I wouldn't have time to list even a 10th of them here. But I'd be happy to send you that list. But it includes big companies like Texas Instruments, Intel, Google, Apple, so all those top companies, as well as some research labs that you may not have heard of, like MIT Lincoln Labs, Sandia National Labs. Research labs like that. It can include smaller startup companies. So we have the full range. Again, I'd be happy to send you that list if you'd like it.
Okay. And do you have some information about starting salaries within your department as well?
Starting salaries. They're pushing. I think the average is close to 80,000, if my memory serves me. I think the computer engineers are edging up a little bit more over electrical engineers, but it's really close, within 5,000 a year or so. Yeah.
Okay. Very good. And then I had another question. Is it a possibility to do study abroad with
Absolutely.
a degree?
Yeah. So we've identified certain terms that are more favorable for doing study abroad and how to fit that into your curriculum. And if we don't have information up on the international programs website, it should be there. So I'll check and verify that. But I can also send you information about that. Yeah. We've identified several schools in Australia, Korea. We have a relationship with a school in Germany. There's a faculty member from that school that comes here to teach, usually in the fall, not this fall because of things happening. But we have relationships with international programs all over the place. Yeah.
Okay, very good. And then another question is, there research opportunities available for first-year students?
Research opportunities. First-year students is a little difficult because you haven't quite gotten too much into your major courses yet. But usually by the end of your sophomore year, going into your junior year, and certainly throughout your junior year, we have something called an independent study course. And that's a great way to get involved in a project with a faculty member. So if a faculty member is doing work or research or has projects that they're working with industry, or even if you just come up with an idea for a project and you really want to work on this project, and you need a faculty member to help you out, you can get credit for it. So there's a lot of opportunities to do research and work on projects. We have several faculty with active research programs. So I'm involved with Dr. Chang in our department, and we're doing research in computer architecture. There's Dr. Wheeler, who's doing research in electromagnetics. We have Dr. Kim, who's doing research in communications and 5G cellular technology. We have Dr. Throne, who's doing breast cancer research. So we have a lot of research opportunities within the department. Dr. Joe is doing machine learning research with a COVID test, a rapid COVID test company that's developing a new test for like a 5-minute, 10-minute test for detecting COVID. So there's a lot of opportunities going on in the department. Yep.
Great. Okay. Would you like to give them your contact information if they would like to follow up?
Yes, be happy to. So you can always go to the Rose website and find my information on the website. That's probably the easiest. But there's also my phone number is 812-877-8341 is my office phone number. My email is my last name, so Simoni, Simon with an I at the end, at rose-hulman.edu. I'd be happy to answer your emails, take your questions. If you want to call, be happy to talk to you. We can also set up an online meeting with Microsoft Teams. I'd be happy to chat with you online. Just let me know how I can help or answer your questions.
Okay. It looks like maybe we did have a difficulty with our video here. Go figure for
okay.
Institute of Technology. I think that we do have the video going now in case there was an issue, and I hate to have you go over everything that you just did. But it looks like we are live. And again, my name is Lisa Norton. I'm the Dean of Admissions here at Rose-Hulman. And this was our very first Tuesday talk introducing academic departments. And I have with us our guest, Dr. Mario Simoni from the Electrical and Computer Engineering Department. I don't know how much of that you were able to see early on whenever we started the broadcast earlier. He just went over several aspects of the department. And I'm going to ask him to just do a quick overview once again for those of you that were not able to see that. Okay. Just talk a little bit about the majors, electrical engineering, computer engineering, and the opportunities within that. I'm sorry to have you do this again.
No, it's fine. It's fine. So we have two majors in our program, electrical and computer engineering. The computer engineering focuses a little bit more on the digital computing hardware, how a microprocessor works, how software works with the hardware, understanding the relationship between the software and the hardware. Electrical engineering is a little bit more general degree, and it's going to pick up areas like control systems, electromagnetics, and signal processing that the computer engineers have access to, but the electrical engineers are required to take more of it. And so that's an overview of the difference between those two programs. Right now we don't allow double majoring between the two programs, but it's possible if you're majoring in one domain that you can pick up courses, one or two courses of interest from the other domain to pick up those areas. We have so many internship and job opportunities in our department. As I mentioned earlier, I can send you a file that'll have 200 companies over the last 10 years that have been, not even that have hired, but have been looking for our graduates. But so we have plenty of opportunity. There's so much demand in these fields that we simply cannot produce enough graduates. We have 3 career fairs every year. The fall career fair is the biggest. We have about 250 companies that come to the fall career fair every year, different companies. And that's not, even within one company, they may be hiring from many departments. So that's just companies. And then of those companies, usually over about 150 or over 150 are looking for electrical and computer engineers. And we only graduate about 80 to 100 electrical and computer engineers every year. So it's impossible for us to meet the demand for these fields and industry. So that being said, we don't have a formal internship and co-op program. That's another question that a lot of students have. So Rose-Hulman as a whole does not have a formal co-op or internship program where you're required to do that as part of the degree. But because our field is in so much demand, if you're looking for one, you will find one. So most of our students have an internship or co-op by November, and those that continue to look throughout the year because they didn't look in November still have opportunities to find them. So there's more than ample opportunity for you in these programs.
Okay, wonderful. Yeah. And then just to reiterate one more time, there was a question earlier about do we practice electrical design in the curriculum? Yes. And if you could go over that one more time, I'd appreciate it. Sure.
So the question was about design. So we start with design your first or second quarter as a freshman. So we have a freshman design course that we think is really exciting. It combines hardware and software. You're learning how to use an embedded system, an Arduino Uno microcontroller. And you're learning how to connect circuits up to it and how to use it to drive circuits. And there's a series of mini projects in that class where you have some design aspect to each of those projects. And those build up to a robotics project, a team-based robotics project at the end of the term that's a competition between all the other teams in the class. And so that's usually our highlight of the fall term. A lot of people, even from outside the department, come to watch that. So that's a lot of fun. And then last year we did, I can't say Pokemon, that we didn't actually use Pokemon, but we did something like Pokemon as our theme in capturing other creatures and using those creatures in the competition. So then in the junior year, you'll do a more complicated project. Again, it'll be every team will have a similar project. This past year, we had the students design a power supply for a little RC-sized autonomous vehicle, and the vehicle had to drive itself around the track, and they had to be able to recharge the power supply for the vehicle within like 3 minutes and fully charge it, and then it had to run for 2 minutes. So things like that that we do in the junior design class, where you're learning a little bit more design process and you've had some experience in your other courses. So we allow you to utilize that knowledge that you've gained in a more complicated design problem. And then in your senior year, you're going to have a project all year long, and that project is usually an industry-sponsored, or it's a client-sponsored project. They're all client-sponsored. It's just a matter of who that client is. So the client could be an industry like Texas Instruments. Let's see, we have another one from a startup company this year. So we have all kinds of different industry clients. We also have nonprofit clients. For example, University of Nebraska Medical Center, we have a project with them. We have a project with the Wabash Valley Railroad Museum here in town, where the students are designing a solar panel power supply for the rail cars that they have at that museum, so that they can install fans and lighting and run it off grid at the Railroad Museum. So lot of interesting projects, and as I said, you'll be on a team of 3 to 4 students, and you'll be working on that project all year through fruition.
Okay. And then I had another question. What does the typical freshman year look like for somebody that wants to study electrical or computer engineering in terms of the curriculum?
That's a great question. Yeah. So the first year, the problem is there is no standard anymore, because we have so many students coming in with different amounts of credit and starting in different math. But I'll tell you the kind of the vanilla that we have that we can show where if you start at the very beginning and go all the way through. So you have 3 terms. We have 3 10-week terms a year. So you have 3 terms of calculus, 3 terms of physics. You have our freshman design class. You start with a computer science and programming class. And then at the end of the year, we have an introductory signal processing class, and we have an introductory circuits class. So you start building circuits, and you'll start doing some signal processing on things like video and audio files and things like that. So it's a fun-filled year. And then we have our humanities and social sciences and the arts. So we have one of those electives, plus a freshman writing class. So it's a great year.
We have just a couple minutes left here before we move on to our second department of the night with engineering, physics, optical engineering. But just reiterate one more time for the audience some of the specialty areas within electrical and computer engineering. That question came up one more time.
One more time, yes. Sure. So let me talk about some of those areas again. Okay. So we have within electrical and computer engineering, there's analog circuits and design of circuits. And so it's hard to describe this, because this is all the stuff that's hidden from you in your cell phone. But your probably a good example is your radio in your cell phone, the actual circuits that transmit the signals to the base station and receive the signals from the base station. So other examples are sensors and getting signals from sensors and things of that nature. So the best example of an analog circuits company is Texas Instruments. And I know you think that they only do calculators, but most of their work is in the analog circuits industry. Then there's signal processing. I've mentioned signal processing before, and this is the idea that we're taking all this information from sensors, and we need to do something with that information to extract what it is that we're interested in. So for example, let's say I have a party. There's a party you go to, and lots of people talking in one room. Well, if we can set up a few microphones around that room, and we record the signals from all those microphones, store them on our computer, then we can write some software to sort of combine all those signals together in some way. And we could extract one person's voice. Even though all of those microphones recorded all of the people speaking all at the same time, we could get one person's voice out of that, and we could probably track where that person was in the room as they moved around the room throughout the night of that party. So that's signal processing, that combining and extracting of information. Electromagnetics is where we're using electromagnetic energy for anything that has an antenna. Could also be things like radar, and your adaptive cruise control uses radar to adjust the speed. There's digital system design. So digital design is anything like your microcontroller or your microprocessor in your computer. It could be like designing the graphics card, computer memory. All these things are digital design. Control systems is the idea like cruise control, where you're going to enter in a set value, some speed you want to go to, and then the control system does all the management of all the behavior within the system to keep it at that set point. So if you think about cruise control, it's got the car has to sense how fast it's going. It's got to sense how much gas is going to the engine. It's got to adjust the amount of gas going to the engine, and it's got to do it such a way that you don't get jerked back and forth while you're driving down the street, right? You want it to smoothly go to that speed. So that's control system design, and that's useful in robotics. Of course, autonomous vehicles. Tesla has lots of control systems in their vehicles for all kinds of things, not just cruise control. What's another one here that I'm missing? We have embedded systems, which is like my Fitbit here. This is a computer. So embedded systems are where we're taking computers and we're using them for very special purpose applications. And so it takes in the same inputs over and over again. And it produces the same outputs over and over again and interacts with an environment. So it's a combination of hardware and software working together for a specific purpose, as opposed to a general purpose computer like your laptop or your desktop. And so embedded computing is going into everything. Went to buy a refrigerator, or went to look at refrigerators the other day, and it's got a computer on the front of the refrigerator. You know, that's an embedded computer. It's a computer with a specific purpose. Your automobile has tons of embedded systems in it. So that's another area. Communications. So we're all excited about 5G cellular communications. So that's all electrical and computer engineering in there. That's all what we do. And then machines and power is one of the areas that I forgot. So machines and power is any sort of electric motor and control and driving of that motor, all the power generation, everything, you know, from the power plant to the wall outlet. That's all electrical and computer engineering as well. And that's becoming much, much more complicated. A lot of computer engineers are actually going into the power industry in order to do smart grid technology, you may have heard about, right? Prevent blackouts and things. So I think that's all the areas. That's what I'm going through the checklist in my head. I think that covers them all. Yeah.
Very good. We have a comment, so this is very interesting stuff you're talking about. So.
Oh, good, great. I love it.
Great.
So I hope we get to see more of you.
Yeah. So if anybody does have questions about electrical or computer engineering, Dr. Simoni would be happy to answer emails or phone calls if you have them. And so check out the website for a lot more information. I'm going to have him give his email address one last time before we take a quick break to move to our next department.
Yeah. So best way to get in touch with me is send me an email, and then we can set up a time to chat, or we can continue with email or set up a phone call. So my email address is SIMONI, so it's like Simon with an I at the end, Simoni, at rose-hulman.edu. And again, you can find my email address online as well on the Rose-Hulman website. My phone number is 812-877-8341. And I love to hear from you, so please contact me. I'll be happy to send you any other information I can to help you make your decision.
Thank you so much for your time tonight. We really appreciate it.